Assalamualaikum warahmatullahi wabarakatuh. My name is Ashraf bin Khalid, matrix number B0920104226. Fundamentally, steam cycle came from Rankine cycle theory. The Rankine cycle is an idealized thermodynamic cycle describing the process by which certain heat engines, such as steam turbines or reciprocating steam engines, allow mechanical work to be extracted from a fluid as it moves between a heat source and heat sink. The ability of a Rankine engine to harness energy depends on the relative temperature difference between the heat source and heat sink. The greater the differential, the more mechanical power can be efficiently extracted out of heat energy, as per Carnot's theorem. In a reheat cycle, the expansion takes place in two turbines. The steam expands in the high pressure turbine to some intermediate pressure, then pass back to the boiler, where it is reheated at constant pressure to a temperature that is usually equal to the original superheat temperature. This reheated steam is directed to the low pressure turbine where it is expanded until the condensate pressure is reached. History. The Rankine cycle is named after William John McCone Rankine. Since July 5, 1820 to December 24, 1872, a Scottish engineer and physicist, he was a founding contributor to the science of thermodynamics. Rankine developed a complete theory of the steam engine and indeed of all heat engines. His manual of engineering science and practice were used for many decades after their publication in the 1850s and 1860s. The Rankine cycle is usually based on water as a working fluid. Applications of the cycle with different working fluids started to appear soon, such as the naphtha boats. The applications of heat cycle and reheat cycle. Firstly, the Rankine cycle closely describes the process by which steam engines commonly found in thermal power generation plants harness the thermal energy of a fuel or other heat source to generate electricity. Mixed gas steam cycles have been proposed to increase the efficiency of gas turbines. Besides that, these cycles allow exhaust heat to be recovered for reuse within the gas turbine plant and are an attractive alternative to combined cycles for small and middle-range industrial power plants. The purpose of a reheating cycle is to remove the moisture carried by the steam at the final stage of the expansion process. And lastly, the reheat cycle increases the turbine work and consequently the net work of the cycle. This is accomplished not by changing the compressor work or the turbine inlet temperature but instead by dividing.
Hi, my name is Ilham Noraede, matrix number B09201038. I'm going to present about components of basic and improved cycle for steam cycle. There are four of basic steam cycle: pump, boiler, turbine, and condenser. For pump is compression of the fluid to high pressure using a pump. Next is boiler. To compress fluid is heated to the final temperature, which is at boiling point. Therefore, phase change occurs from liquid to vapor. Other than that, turbine is expansion of the vapor in the turbine. Last is condenser is condensation of the vapor in the condenser where the waste heat goes to the final heat sink, the atmosphere of a large body of water. To improve steam cycle, there are three methods: decreasing the condenser pressure, superheating the steam to a high temperature, increasing the boiler pressure. Steam leaves the turbine and enters the condenser as a saturated mixture in line with the corresponding pressure of steam in the condenser. Lowering the condenser pressure always helps in delivering more network in the turbine, as more expansion of steam in the turbine is possible. With the help of the TS diagram, the effect of lowering the condenser pressure on performance of the cycle can be seen and understood. Superheating of steam is the phenomena in which heat is transferred to the steam to superheat the to superheat the steam to higher temperature by maintaining the constant pressure in the boiler. The shaded area in the above TS diagram clearly showing the increase in network 3344 on account of increase in superheat temperature of steam. Additional heat input in the form of energy leave the cycle works. Example, increase in work output surpass the additional heat input and heat rejection. Thermal efficiency of the Reheat cycle increases on account of increase in steam temperature. In- Increasing the boiler operating pressure and thus in a way related with the temperature at which boiling is taking place in the boiler, thus the thermal efficiency of the cycle increases. By the help of the S diagram, the effect of increase in boiler pressure on the performance of the cycle can be clearly seen and understood. That's for all for the component of basic and improved cycle for steam cycle. Thank you.
Assalamualaikum and a very good day. My name is Ahmad Farid bin Mohamed. Matric number B092010027. Now we are proceed to the working principle of steam cycle. The steam cycle basically work on Rankine cycle. The Rankine cycle is the basic operating cycle of all power plant, and it involves all the constant evaporation and condensation of the working fluid. The operating fluid chosen is primarily determined by the temperature range available. The Rankine cycle operates in the following step. The first step is isobaric heat transfer. The feed pump sends high temperature liquid into the boiler, which is heated to saturation temperature. As more energy is added, the liquid evaporates until it completely transforms to saturated steam. The next step is isentropic expansion. In the turbine, the vapor expand producing work can be turned into electricity. As the process advances further to the two-phase area, the expansion is resisted by the temperature of the cooling medium and the erosion of the turbine blades caused by liquid entrainment in the vapor stream. The vapor quality of the exit should be more than 90%. That is isobaric heat rejection. The vapor-liquid mixture that exits the turbine is condensed at a low temperature, commonly in the surface condenser that use cooling water. The pressure of the vapor is much below atmospheric pressure in well-designed and maintained condenser, reaching the saturation pressure of the operating fluid at the cooling water temperature. Last step is isentropic compression. In feed pump, the condensate pressure is increased. Pump effort is generally mirrored due to the low specific volume of liquid, and it is frequently overlooked in the thermodynamic calculation.
Assalamualaikum. My name is Ahmad Shapawi. My metric number is B0920100069. Okay, now I'll continue with working principle of Reheat cycle. Okay, for the working principle here is nearly same with the steam cycle, but for reheat, there is extra turbine, as we can see at the diagram beside. Okay. The function of the turbine is to split the expansion in two and injecting reheating between both turbine stages is an excellent approach for getting rid of the minimal vapor quality issue at high pressure. Okay. Then the high temperature vapor enters the high pressure turbine first, which is the pink one. Okay. After number 3. Okay, then the medium pressure vapor is then warmed before being reintroduced to the boiler. Okay, uh, at number 5. Then in the low pressure turbine, the high pressure temperature, medium pressure vapor is eventually expanded at number 6. Okay, that's all for me. Thank you.
Assalamualaikum. My name is Annisa Aishah Binti Roziman. Metric number B0920101443. I will explain my part, which is advantages of Rankine cycle and disadvantages of basic steam cycle. For advantages of Rankine cycle, low turbine revolution per minute, allowing direct driving of the electric generator in many applications without gear reduction. Next, low mechanical stress on the turbine owing to the vertical speed. Next, enhances the thermal efficiency. Next, decrease the steam flow rate per kilowatt hour. And lastly, no blade erosion due to the lack of moisture in the vapor nozzles. For the disadvantages of basic steam cycle, steam turbines are inefficient, under part load compared to the reciprocating engines. They require more time to start than gas turbines and almost certainly than reciprocating engines. Third, at the end of the combustion process, the steam power plant emits smokes and gases that might contaminate the surrounding environment. And lastly, the basic steam cycle relatively expensive overnight cost. That's all for my part. I will continue with the next person.
Yes, Assalamualaikum. My name is Dhareemy Hilman Rozali. So I will present for suggestion to further improve the cycle. So first of all, we can improve the cycle by reheat the ranking cycle. This is to take advantage of increased cycle efficiency at higher boiler pressure without affecting the moisture content of the steam in the final stage of turbine. And this can be achieved by expanding the steam into stage by reheating between the steam turbines. So next, we can increasing the boiler pressure with subcritical parameter by increasing the boiler operating pressure and thus in a way relate with the temperature at which boiling is taking place in the boiler. So this can make the reduction in the heat rejection to cooling water in the condenser. So and lastly, we can modify the ranking cycle. For example, the expansion of steam in the reheat cycle occur in two stages. And by doing this, we can adopting a single reheat cycle in thermal power plant cycle efficiency and enhance it by another 4 to 5%. So that's all for me. Thank you.